Namaste and welcome back to the DSA class. Now we are going to be solving a very commonly asked question on recursion, and the question is to find all the subsequences of a given string. Now immediately the question that comes to everybody's mind could be, what is a subsequence, Rohit? Very simple. According to mathematics, a subsequence is defined like this. So a subsequence of a given number is a subsequence that can be derived from the given sequence by deleting some or no elements without changing the order of the remaining elements. Confusing? Let me help you understand. Let us assume that the given string is ABC. Now I am putting a box in which I am going to show you all the different subsequences of ABC. So according to the definition, you may not delete anything. If I don't delete anything, I will get ABC. Now ABC is a subsequence of ABC where I have not deleted any character. Now let us assume I decide to delete A. Then the subsequence I will get is BC, and you can see I deleted A but I didn't change the order of BC. I didn't change the order of BC, right? So you deleted some elements without changing the order of the other elements. So BC is a subsequence. Now I can delete B, in which case AC is a subsequence. I can delete C, in which case AB is a subsequence. Now don't think you can delete only a single character. You can delete multiple characters. Assume I preserve A and delete B and C. Then A is a subsequence. If I delete A and C, B is a subsequence. If I delete A and B, C is a subsequence. If I delete both or all three A, B and C, then the empty string is also a subsequence, which I am just showing as a dash. So all these are the subsequences. Now I hope the definition makes sense. Now just for you to know this, I am giving you this information. If given a string, you want to know how many subsequences could be there. There is a mathematical formula which is expressed in terms of the length of the given string. So the number of subsequences is equal to 2 to the power the length of the string. And you know, in this case the length is 3, so 2 to the power 3 is 8, and as you can see 1, 2, 3, 4, 5, 6, 7, 8. Exactly 8 strings are there. Any confusion till here? And if you are wondering why this formula works, well, it's very simple. What is the length of a string? 3, which means 3 characters are there. Now in every subsequence you may pick this element or you may not pick the element. You may pick the character, you may not pick the character. So you may pick, not pick, pick, not pick, pick, not pick. These are the options you have, which means every position you have 2 options, to pick the character or not pick the character, right? So there are 2 options, 3 positions. 2 to the power 3 is 8, simple combinatorics. I hope you're able to think. So I hope what is meant by a subsequence is clear to everyone. Now how do we go about achieving this? Through recursion. It's because it's a commonly asked recursion question, right? Now you must understand one thing. See, whenever you want to solve something recursively, you must always ask yourself the question, can it be solved recursively? And I have previously also helped you understand that to check whether something can be solved recursively, 3 points you have. First point is, can it be broken down into smaller problems? Second point, are the solutions of the problems dependent on each other or the previous problem, right? Is there a base condition? Now if these 3 questions you get satisfactory answer, definitely a problem can be solved recursively. Now can this subsequence problem be solved recursively? Yes, a very elegant solution you can write. Iteratively it would become very difficult, but recursively it is very easy. What do I mean? See guys, I have ABC. This is my given string. Now would you agree that to find all the subsequences of ABC, I can actually break down the problem into a smaller problem and say, hey listen, I would like to first find all the subsequences of BC. I'll remove BC. Now don't you think I can further go ahead and say that to find all the subsequences of BC, I will again break down the problem to a smaller problem and say that I will first find all the subsequences of C. Further, if I try to break it down, it will become an empty string, and the moment it becomes empty, I must stop. Now you may ask, really, to find all the subsequences of ABC, can you first find BC, then can you find C, and then can it be merged together to get the final solution? Does it work? Let me show you with an example, okay? First and foremost, let's start in the reverse order. So let's start with C. Now I'm starting with C. Now what are the different subsequences of C? Very simple. You have only two options, right? You have only one character. So it is 2 to the power 1, right? So two combinations of you have. Now what is the two combinations? Either you can pick C or you cannot pick C. If you don't pick C, it will be an empty string. I hope you're able to think. So what are the subsequences of C? C and an empty string. Now see, C you understood. Now I'm adding B to it. I'm adding B to it. If I add B to it, would you agree? This B is added extra. Now I may pick it, I may not pick it. Let us assume I don't pick B. If I don't pick B, would you agree that this is the exact same subsequence that I will get? If I don't pick B, then if only C was there, C and empty string. Now I may pick B. If I pick B, then all you have to do is add B to this, add B to this, which means it will become BC and B. Simple, simple. Which means, would you agree that to find all the subsequences of B, first if you knew the subsequences of C and to that attach B, you have got your answer. So would you agree that for BC, first C if you know is enough? So are you able to break it down? Now see, to BC I am adding ABC. Now if you look at it, assume I don't pick A. I don't pick A because subsequence means what? You can delete one or more characters or 0 or more characters to be precise. So I will not pick A, which means BC. BC's subsequences are nothing but this. So as it is, I can copy paste it. Now if in case you were to pick A, then what will happen is attach A to all these combinations. Attach A here, attach A here, attach A here, attach A here. In which cases you will get AC, A, ABC, AB. And these are all the combinations of or subsequences of ABC. To find all the subsequences of ABC, all you have to do is first find all the subsequences of BC and then create another combination where A was added. Now to find all the subsequences of BC, all you have to do is find all the subsequences of C and add B to it. Are we able to think? Simple, simple. Now obviously you cannot break it down even further because it will become empty. So definitely it is possible to break it down. It is possible to break it down, which means can the problem be broken down into smaller problems? Yes. So I'm making it green in color. Next, are the solutions of the problems dependent on each other? 100% it is. So I'm making it green in color. Is there a base condition? 100% there is a base condition because ABC can be broken down into BC, BC can be broken down into C. When I break it down further, it becomes empty. Once it becomes empty, I am stopping. So there is a base. It is not going to be infinite recursion. There is a base. How we're able to think. So even this becomes green. So now that we understood that certainly we can be solving it recursively, now let's go try to build the recursive solution for this. Now you can notice something very, very important here, right? If you notice it, these are all the subsequences of C, subsequences of BC, subsequences of ABC. Now if you notice something very, very important, ultimately whatever is there in this C, BC and ABC are nothing but my string. My string is initially ABC, then it will become BC, then it will become C. So this is nothing but my string. So every time the original string has to be broken down into smaller strings. And every time, how are you breaking it down? ABC, you removed the first character, then it became BC. In BC, you removed the first character, then it became C. In C, you will remove the first character, it will become empty, you will stop. How are you able to think? Now, so on one end, I have my string. On another end, I have all these subsequences. Each one is an answer, because each one is a subsequence. And look at this very interestingly. Let's start with C. Pick C, don't pick C. I'm putting green and red. Pick, don't pick. In BC, don't pick B, pick B. How are we able to think? In which case it is red and green, and just to make the color combination I'm just swapping this. So here also it is first you will not pick, then you will pick. So it is red and green. Here also it is red and green. If you look at this ABC, right? Don't pick A, pick A. So red and green. How are we able to think? So naturally these answers somewhere I have to store. Each one is an answer. Each one is an answer. Somewhere I have to store. Where will you store it? So for that I require another variable which I will call it as answer, and I'm just showing you like this. So what I will do is I will have a variable, yes, initially it will have my string which is ABC. I'll have a variable called as answer which is initially going to be an empty string. This is going to be an empty string. Now what I will do is I'm going to create a function called as get subsequence, in short as GSS. To GSS I will pass yes, I will pass answer. Now what we have to do is understand what we must do inside the body of GSS to ensure that we will ultimately print all the subsequences. Hope you're able to think. How are we going to do it? Let me show you. Now let us try to understand how to write this recursive function by first building the recursive tree. Okay, now listen to me. First time when we call the function, we will be passing two values. The string yes, which I am assuming as ABC, and the variable answer which is initially going to be empty. Okay, now listen to me guys. You know that whenever you are creating subsequences, ultimately the decision is whether to pick a character or not pick a character, whether to delete a character or not delete a character, right? Now let us assume that I will first say that, hey listen, I would like to pick A, or I would not like to pick A in my subsequence. These are the only two choices I have. So watch it. This is the choice where I pick A. This is the choice where I do not pick A. So I'm writing this not pick A. Any confusion? Now forget about this side for the time being. Let us look at this side. Now what do you mean by pick A? You're saying if you pick A, you're saying that you are now trying to generate all such subsequences of ABC which contains A. Now what are the subsequences that contains A? Would you agree ABC is one subsequence? Would you agree AB is another sequence? Would you agree AC is another sequence? Would you agree A is another sequence? These are the only subsequences which have picked A in them. I hope you're able to see. I hope you're able to understand that this is what I'm trying to generate. Now, very simple. Now I want to pick A. Now if I have to pick A, then you know all these answers, each one is an answer. All these answers must have A in them. All these answers must have A in them. So would you agree that my answer which is empty must now have A in it, must have A in it. So what I am going to now do is, I am going to recursively make another call. Now what will be yes, what will be answer I will tell you. But one thing is, I know that because I've picked A, answer should have A. It's all starting with A, so answer should have A. Now what I want to do is, I want to add A to this answer and send that as the new answer here. I want to pass A as the answer here. So how will I do that? A is your first character. Both in Python as well as in Java, there are ways in which you can access the first character from the string. So I'm just writing like this. See, old answer plus character at the 0th position. Character at the 0th position is nothing but the first character. I want to take the character at the 0th position. If I concatenate them together, empty plus character at the 0th position is A. I will get A, and that A will be my new answer. How are you able to think? However, what will be yes is the question. Now I want you to think. See, let me just take you back. What you must understand here is, look at this. ABC is all the sequences you wanted in which you had selected A. Ultimately, this is what you are trying to achieve is. All the sequences in which you have picked A, you are trying to select. Now, all these sequences that you have picked A is what? Is nothing but all the subsequences of BC to which A has been attached. So in a way, can I say that if I want all the subsequences of ABC where I have picked A, I first need all the subsequences of BC. So am I able to break my problem down? So now I'm taking you back. Answer required A, so you know how to add it. Now to find all the subsequences of ABC where you have picked A, you first need all the subsequences of BC. So would you agree that I need to break this down into a smaller problem which is BC? So how will you break it down into a smaller problem? Simple. You have to eliminate the first character and then take only the remaining characters. If you eliminate a character and you take the remaining characters, what you're doing is finding a substring, a smaller string from the original string. Both in Java as well as Python, all of you know how to calculate a substring. Here I would just tell that from my string, yes, I am trying to calculate the substring from the first position. What does that mean? 0 is the first character. From 1 till the end I want the string. From 1 till the end means B and C I will get. So S dot substring of 1 means A will get eliminated, and what this will give me is BC, and that I will pass as my string. Which means recursively I made a call by appending or concatenating the first character to my answer because I am picking it, and breaking down my original string into a smaller string by eliminating the first character. Simple as that. Now what you are trying to say is, hey listen, give me all the subsequences of BC where A has been picked. That is what you are trying to say. Give me all the subsequences of BC where A has been picked. Now because it's recursion, our aim is to keep breaking down the problem till you hit the base. How can you break this problem down? Again here guys, you have two choices. You want all subsequences of B. Now in subsequence of B there are further two choices. Such subsequences where you will pick B, you will not pick B. Where you will pick B, you will not pick B. Forget about not pick for the time being. Let us stick to picking B. Now, when you say picking B, what are you talking about? You are talking about BC, you are talking about B. I hope you are able to think. These are such subsequences where you are picking B. I hope you are able to think. Anyways, let me just remove that. So now watch it. Here if you notice, it's very easy. I'm again taking you back here. These are the subsequences of BC. You want all such subsequences of BC where B has been picked. B has been picked. Now if you look at it carefully, what is this? To solve for this, all you need is all the subsequences of C. You need that first, and just attach B to it. You will get all subsequences of BC where B has been picked. So would you agree? To solve for all the subsequences of B where B has been picked, first you must know all the subsequences of C. Are you able to see the recursion happening here? Are you seeing the breaking down of the problem happening here? Which means, would you agree? Because I've told, hey, I want to pick B, ultimately what I'm saying is, in my answer, I want all these where B has been picked. So I want A, B, C, and I want A, B also. That's what I'm saying. So answer already has A. Now because I'm picking B, to my answer B has to be attached. So how will you attach B to the answer? Simple, you know. This is the 0th character, take the 0th character, append it to answer, which means I will get AB, and that I will pass as the new answer. Now you know to find all the subsequences of BC where B has been picked. First you need to find all the subsequences of C, which means recursively you should call for C, which means you have to remove B and send C, which is nothing but again finding the substring where you start from 1. If you start from 1, 0th character is eliminated, till the end you will go, which means only C is remaining, send C. Now this is my next recursive call. I hope you are able to understand. Ultimately, now string is C, answer right now is AB. Now what am I doing? I have two choices, pick C, not pick C. Pick C, not pick C. Now forget about not pick C, let us stick to picking C. Now picking C means what? Picking C means I picked C. Obviously that has to be added to the answer. So how will you add it to the answer? All of you know by now, so I'm directly showing you. If I concatenate, I'll get A, B, C. That I will pass as the answer. Now to ultimately solve for C, a single character, what you need to know is break it down one more level. If I break it down one more level, if I find the substring from 1, ultimately this will become empty. So see, empty string goes. The moment it becomes empty, you know you can't break it down anymore. So you hit your first base case. And look at the answer, A, B, C. Haven't you got one subsequence where you have picked A? A, B, C you have got? Print it. So I'm just printing it there. I'm printing A, B, C. And since you hit your base case, after printing, return means control will go back on top. This side was over. Now I have to write for the not pick condition. Now not picking C means what? Not picking C means what? To the answer I must not add C. That is what it means. To the answer, if I should not add C, all I have to do is I don't have to concatenate. Without concatenating, as it is I will pass answer, which means answer will be A, B only. And string ultimately, to find all the subsequence of C where C is not picked, ultimately you have to break it down. For empty you have to do. So again, if I find substring, it will become empty, I will send it. Empty means base condition. Base condition means print. If in case the length of the string is 0, empty string means what? Length of the string is 0. If in case length of the string is 0, you hit your base condition. Just print your answer. I have printed my answer. After which, return. So you see, AB got printed, right? After you return, everything here is over. Again you will return. Pick B was over, not pick B. Not pick B means what? Don't attach B, don't concatenate B to the answer. Send answer as it is. Obviously here you will find the substring. If you find the substring, it will become smaller. Only C you will send. Again you have two options. Pick C, not pick C. When it comes to pick C, same thing guys. First take C, attach it to the answer, send it. You will get AC. Obviously if you find the substring, this will become empty. The moment it becomes empty, you hit a base condition, print it. After printing, return. Now you will come to not pick C. Not pick C means what? Don't append it to the answer. Don't attach. Don't concatenate. I will not concatenate. As it is, I will send. Obviously, if I find substring, it will become smaller. Base condition I have hit. Length is 0. Print A. Are you see? Correctly it worked. I got ABC. I got AB. I got AC. I got A. Would you agree? For my string ABC, you have found all the subsequences where A has been picked. Beautifully it works. Great. Done. Return, return, return. Now pick A is over. Come to not pick A. Not pick A means what guys? Answer was empty. Don't append A to it. Which means I will not do concatenation. As it is, I will send the answer. As it is, I will send the answer. Obviously, to find all the subsequences of ABC where A is not picked, first I should find all the subsequences of BC, which means same logic applies here also. Find the substring, send it, BC. Again two options, pick B, not pick B. Now let's go to pick B. If I go to pick B, what does it mean? Take B, append it to the answer. Answer becomes B, send it. Find the substring here. B will go, it will become C, send that. Again you have two options, pick C, not pick C. If I say pick C, then what I should do is take C, attach it to the answer. It will become BC. BC will be sent to the next call. Substring means here only one is there, it will become empty. Empty string is sent. The moment empty string is encountered, base case is encountered, which means I will directly print whatever is there in the answer, in which case I will get BC. So do you see, I've got the first combination. I've got the first combination where I have not picked A, but picked B. Not picked A, but picked B is first combination is BC. Beautiful. Next done, return. Now not pick C. Not pick C means don't concatenate, send answer as it is. Find the substring, it will reduce, it will become empty. Empty means base case, print the answer. Return, return, now comes not pick B. Not pick B means what? To the answer, don't append B, don't concatenate B, send answer as it is. Substring you will find, this will reduce in length, you will get C, send C. Again two options, pick C, not pick C. Not pick C means don't attach, pick C means attach it to the answer. So I'm concatenating, empty string will become C, send it there. This substring of 1 means it will become empty. If it is empty, then I have hit base condition, print the answer C. Are we able to think? And then obviously return back, not pick C means do not concatenate, send answer as it is. Obviously here you will reduce it because it's recursion, you will break it down into a smaller problem. You will hit the base because it is empty. Base means print it. And you know, one of the combinations is empty string also. And then return, return, return. That's it. Now we're able to think. So ultimately, if you look at all my base conditions, 1, 2, 3, 4, 5, 6, 7, 8. How many combinations are there? How many subsequences are possible for a string of length 3? It is nothing but 8 combinations. And all 8 combinations perfectly you have got. Now the only other question is, how are we going to write the recurrence relationship? Simple, simple. Watch it. What I will do is, I will just go here And I am going to now create one a function called as GSS, which means generate subsequences. Obviously, you will pass your string yes and you will pass your answer. Inside this, what is the base condition, because we don't want infinite recursion to happen. So I will just tell if in case, right, the length of my string yes, if this is equal to 0, I've hit my base. If I hit my base, all I have to do is I have to print my answer, and after that what should I do? All I have to do is return. Would everyone agree? Simple. Right? But if it is not the base condition, there are two conditions: picking, not picking. So for picking, how will you write? Very simple. Again make a recursive call where the original string has to be reduced by one character from the left. So for that, you have to just find the substring from the first character. 0th character will be removed. Until the end you will go. And that is what I am also just telling. Very simple. I will just find the substring from the first position. And because I am picking, to my previous answer, I will attach the character at the 0th position. Hope you are able to think. Great. This is picking. Not picking is very simple. The string will still be the substring only from the first position. But my answer, I will not attach the first character because I am not picking it. So I will just pass it as it is. What is difficult in this? Yes, it is difficult if you don't understand, but I am sure everybody has understood it perfectly. Now all that is remaining is for us to go write code. Let's do it. Let's write some code. I'll just go create a static function called as static, we will tell just void because we're just printing right now, and I will call this as GSS, so get subsequences. It will accept two variables, the string yes and the answer, which is again a string. Good. And as you guys know, the base condition of recursion here is that when the string length becomes 0. So if in case yes dot length, so you have to call the length method. If it is equal to 0, then I will just print my answer. So sys out answer, and I am just going to return. That's it. Now comes my two choices, to pick or not to pick. So for pick I am writing, so you can just put a comment pick. Now there I will just go, and for pick I am just going to now tell like this, GSS, and first the string has to be reduced, right? So if in case it is ABC, A has to go and it should only be BC. So how do you do that? Call the substring function, yes dot substring, and I will tell 1. If I tell 1, that is the beginning index, automatically till the ending index it will go, okay, comma. And obviously I have to pick the variable or the character, isn't it? So all I'm going to do is I will tell answer plus character at the first position. So 0 I will tell. Good. Next, not pick. So for not picking, what I will do is I will just copy that, paste it again. And all I have to do is, I'm not picking the variable, isn't it? So I should not append it to the answer. So see, this plus I'll remove, and whatever it is as it is I will set. That's about it. That's about it. All we have to do now is go call GSS. So I'm just going to go down and I'll just create, just call GSS. And I will pass my string yes, and I will also give empty string as the initial value of answer. That's about it. If in case I were to execute, and if in case I were to give A, B, C, and if I press enter, then you can see ABC, AB, AC, A, BC, BC. And there is one empty string also here. I hope you're able to see. It will give an empty string. So perfectly it works, and I hope everybody understood the logic of this program. Now, one question that could be running at the back of all of your minds is, you have not spoken about time complexity when we are discussing recursion. Don't worry, first let's solve all the problems of recursion, and then at the end I will tell you how easily you can analyze the time complexity of any recursion based problem. Anyways, I hope you enjoyed this problem. See you in the next class. Sorry, I'm back. Why am I back? Because there is a small modification that this program can have in the interviews. What they will ask you is to create a list of all the subsequences and return that list. Here we are printing. Rather, they expect you to add it to a list and return that list. Now, what are the different list type data types in Java? You have array list and you have linked list. You can use either of them. So see, it's a very simple modification. I want to make a global array list variable. So I'll just go there, and global means it has to be static. And I will tell static, and I will tell new array list like this. No, it's fine. Okay, anyways, new array list, and this array list I'll put a generic so it can only store in strings, and I'll give this a reference. I'll call it as maybe AL itself. Call this as AL, and then I'll make it a static so that ultimately it is available to everybody in the program or inside the class, right? Great. Now what I will do is I'll just come here and see. All I will do is every time I'm printing the answer, instead of printing, I will add it to the array list. So I'll remove that line and I will tell al.add. What to add? Add the answer. That's it, right? So ultimately that's what I'm doing. It will be adding, and finally what I will do is I will return that. There's no need to return the array list or anything. You just keep adding. So you can't really return the array list because array list is outside. We'll keep adding. Once all the recursive calls are done, this array list AL will be filled like this with all the subsequences. Now you have to just print this array list. So I'll just go down, and here I will call GSS, and the next time I will tell sysout AL. And because this array list is sysout AL, because it's global anyways, it is accessible. Now let us just execute. If in case I execute it and I just put A, B, C and I press enter, so you can see I've got an entire array list, and here it is very clear to you: A, B, C, A, B, A, C, A, B, C, B, C, and there is an empty string. 8 combinations because length is 3, 2 to the power 3. So it works beautifully. Anyways, let's catch up in the next class.